So this video is introducing you about how to change entire radicals into mixed radicals, and the method that I'm going to use here is going to be a perfect square root table. So this is a table that I would like you guys to create and use every time. It's easy to create. So something that we know is that 1 squared is 1. So that means if I do a square root of 1, it is 1. 2 squared, so 2 squared is 4. So that means the square root of 4 is 2. 3 squared is 9, and that will give you the square root of 9 is 3. So I've kind of made the rest of my table, and I would encourage you guys to do the same thing on a blank piece of paper. Just write down this. 5 squared is 25. 6 squared is 36. So I'm looking at these perfect squares. Okay. So it will be great if you can have them written all the way till maybe 15 somewhere in front of you. It really does help you a lot. And I'm just kind of running out of space here, but I would do that. I would do all the way up till 15. So that when you see a question, a big number like this, one of the techniques to use is try to think of the biggest perfect square root you can divide here with. So think of this number that you can divide. We want to split it up so that we can divide this 72 with this biggest number over here. So in a calculator or mentally, you would say, okay, will 72 divide by 4? Will it divide by 9? Will it divide by 16? So the biggest number that it evenly divides by and still leaves you with a whole number is 36. Okay, so that's what I would write it as. I would split my 72 as 36 and 2. This way, you probably have looked at your previous set in this lesson, how they talked about that it's the same thing as writing as two different radicals. So when you write it as a product, you can write it as root 36 and root 2. Here is our perfect square root, which will give us the answer 6. And that's what we want. We always want the perfect square root written first, the part that cannot be written as a perfect square root later, so that when we do take a root of it, it does become a whole number. And so the answer is 6. So the whole answer becomes 6 root 2. So again, when you did this, you wrote this as 36 and 2. You can skip this step if you like to and go straight to this one. So you're writing this as a product of a perfect square root and a one that can't be written as a perfect square root. And this gives you 6, and this will leave you with square root 2. So this is called a mixed radical, where this is a coefficient and there's a radical part to it. Okay. Now let's say if you didn't think of this 36 as your first way of writing it, that's okay. So sometimes what happens is students don't think of the perfect square root first. They might just say, oh, I see 4, and they might go with that. That is perfectly okay too. So they wrote it as 4 and 16. And we know the square root of 4 is 2. Don't write a square root sign again. But then you'll notice that 16 is really big, so maybe there's another perfect square root in there. So that can be maybe a 9 and 2. So the 2 comes down as it is. There is a 9, that 3 from the 9, and this can't be done anything. So this would be slightly little longer, but you'll get the same answer. So we want to try and get to the biggest perfect square root first. So with practice, you will start to pick them up much faster. The same technique will then be applied to perfect cube roots. So you would do the same thing there. You would make a perfect square root table for cube roots as well. So I kind of started one here as well. So 1 cube is 1, 2 cube is 8, 3 cube is 27. So you can carry on. So think of the next one, 4. 4 cube is 64. So the cube root of 64 is 4. And again, you would do the same thing here. You would try to think of the biggest number you can divide by here. Would it be 8? Would it be 64? What number will divide 108? So as you're dividing, you'll notice that 27 works great. And you will do the same thing you did in the previous example. You would write it as cube root of 27. Cube root of 27 is 3. So your final answer is 3 cube root 4. If you do have another process that you're using, that's fine. I just find that this method works faster with practice. If you're still using prime factorization to write all the factors out and then writing the answer, it will work fine. It will take longer and longer as numbers get bigger. So my biggest suggestion here is write down these tables on a piece of paper all the way to 10 or 15 for each one of them, and then use this method to find the square roots and cube roots.